we're going to look at the carbon cycle. We saw this a little bit before, but we're going to do a simulator that experiments with the human factors. So if we're looking at the carbon cycle, we've got photosynthesis, decaying organisms, organic carbon, animal respiration. These are things that we're talking about. These are things that we've been talking about. Now, which one of these is where humans come in? What part of the carbon cycle do humans have the most impact? All right, so you guys go ahead and answer that. Which one of these? So this is question number 1 in the lab. Everybody's on? Everybody's in? Alicia, Julie, open up today's lab. I'm walking you through the first part of it. So you need to have it up and running, okay? Now, the second question, because that first question's way too easy. I'm gonna let you guys do it. So this second one, we've got step 1. Oh my God, just a sec. Sorry about that, guys. Okay, so this first one, we're going to do a simulation. So everybody can see this. We're going to fill out this table. Here is your adjustment calculator. This is what it looks like. All right. So first off, we're going to see that it is, we're using the data table below. We're going to record the total carbon levels in each sink. And the sink is where the carbon is being stored. All right. So if you look here, we want the change in fossil use per year to be 2.5 and the net deforestation to be 1. So I'm going to change this to 2.5. All right. And then we are going to run each decade. Now, looking at this chart, if we do nothing, if we change nothing, it's going to follow this trajectory. It's just going to go up and up and up and up. What we would like to do is to have it stop and flatten out here, this orange one. All right. So I'm going to run it a decade. Over here, you can see we have the atmosphere, we have the soil, the coal, oil and gas, ocean surface, deep ocean, terrestrial plants. These are all sinks. These are all places that carbon can be stored. So coming back here, it says, oops, something popped up. All right, make sure the simulation parameters are set. We're going to start at year 2010. So our atmosphere, 3.9, our ocean surface, 0, deep ocean, oops, wrong one, 0. Over here, terrestrial plants, 700. Soil, 200. Coal, 3,500. And oil and gas, 500. All right. So here we're going to run it a decade. And this is, we want to go to 2060. 2060, year 2060. And we're following along this trajectory because we haven't changed anything. Okay, so this is looking to see what's coming up. Atmosphere went up to 610. Ocean surface, this means the ocean surface has absorbed 123 parts per million extra of carbon dioxide. The deep ocean has absorbed 270 fossil fuels. We're sucking out the fossil fuels. We've taken those out of the ground. Soil, coal, we've taken out coal from the ground. So we're removing it from the sink and we're putting it out into the earth. Soil and plants. A few more plants, soil, a little bit more stored in the soil. So the terrestrial plants went up, soil went up, coal and oil and gas went down because we're using it, we're burning it. Deep ocean, ocean surface has absorbed a lot and the atmosphere has absorbed a lot. Now we're going to go to 2021, run the decade. Oh, and we're shooting up off the chart. All right. So we've hit this peak. We've hit this huge peak. We're doing much, much worse than we possibly could because we went up just a little bit here. So just a little bit of change. We go up just a little bit in the fossil fuel use and we're off the charts here. So go through 1381, 303, this 13, fossil fuels, 0, coal is down to 0, soil has absorbed even more, plants have absorbed even more, quite a bit more. Oh, sorry. All right, there we go. Plants 950. So if we look here, you can see more is in the atmosphere, more is in the ocean surface, more carbon in the deep ocean. We've taken out all of that carbon sink and turned it into a source. So it's a source of more atmospheric carbon. So this stuff went elsewhere, right? Is that right? 38. Oh, 48. Did I put that right? 48. There we go. All right. I thought that was weird. So we used up the fossil fuels and they went into the soil, they went into the plants, they went into the ocean, and they went into the atmosphere. All right. So if only 1/2 of the plants existed, so let's say we took away a lot of the plants. So we didn't have the plants absorbing the carbon like they are here. What's going to happen? If we only have some of the plants, if we have 1/2 of the plants out there, would the CO2 levels be the same? No changes? Would there be higher CO2 or there be lower CO2? If we come back here, it looks like plants have taken up 950 parts per million of the carbon dioxide. If we have 1/2 the plants, is it going to be able to keep the same amount? No. So we're going to see that there's going to be higher levels in the atmosphere because the plants were not able to take as much up. That stuff that it couldn't take up is going to stay in the atmosphere. It's got to go somewhere. How would you change the simulation? So what you're going to do, you're going to change the deforestation rate and double it. So you're going to change that to 2. 2, all right? Deforestation, meaning you're taking the plants. All right, so what's the relationship between increased carbon in the ocean and increased carbon in the soil? As carbon decreases in the ocean, carbon in the soil increases. So let's look. We can reset. We've got this set to 2. We've got more deforestation. You can look here, less in the plants, more in the atmosphere and in the ocean. So carbon increases in the increased carbon in the ocean, increases, carbon in the soil decreases. All right. In a best case scenario, scientists suddenly discover an unlimited, clean, cheap fuel source that emits no carbon dioxide. All right. So you're going to come here and run this simulation. You're going to press none here, and this is where you come in. This is where you're going to do the work. So has everybody gotten to number 6 with me? Yes? You're going to do the same thing. I put in the 2010 already. You're going to fill out the 2060 and 2110. I would recommend using a pencil and paper as you go through this cycle. Okay, so remember to press none here. Click this simulation, click none, and then you're going to run the decades. Do I have any questions? I've got a question. Yeah, Julie, you were late. Okay, I was working on it. You can figure out 1 through 3 because it's fairly straightforward. Okay, did you do, wait, what's number 3? Oh, here's 2. So you'll need 2. Okay. Now, does anybody else have any questions? I'm going to leave that on there. All right. So you guys work on, sorry. There's 3. Okay, there's 2. Julie, here's number 1. Oh, no, I had everybody do number 1 themselves. There's 3. There's 4. And there's 5. All right. Would you guys like to be in breakout rooms? I think so. I think we're going to do breakout rooms. And if you want somebody in with you, let's see. Let's look. Who do I need? All right, guys. Anybody have any questions? I'm going to let you guys work together. I'd share screens. I'd have one person run it, one person write down the information. Call us in if you have any questions. All right. Okie dokie. Everybody's